Greetings. Here we are again. Sorry. The lesson we're moving into today is lesson 8.9, the quadratic formula. The quadratic formula can be used to solve any quadratic equation. So all the other ways that we've covered so far, solving by factoring, solving by using the square root method, those work for some of them. But the quadratic formula, which is right here, will solve any quadratic equation. So again, when we're solving for x. So x equals, and part of this should look familiar to you. We have that opposite of b, and then notice we have that 2a downstairs. That part we use to find the axis of symmetry. Well, we're going to add to that numerator, so we're going to give the negative sign to the b right away. We're going to say the opposite of b plus or minus the square root of b squared minus 4ac. That b squared minus 4ac under there, we call that the discriminant. All of that is in the numerator. So I don't know if you can see this, but there is a radical sign over that discriminant. All of that is in the numerator. So we have a whole bunch to do upstairs. And then downstairs we have the 2a, so the numerator is divided by the denominator, 2a. Okay, we're going to practice 4 of these today, and then you can go to work on your homework. Again, we want the quadratic equation set equal to 0, just like yesterday. And then we're going to identify a, b, and c. I said we don't really want negative a's, but because this is already set equal to 0 and in standard form, we're going to go with it. So we are going to substitute into x equals the opposite of. Every substitution we're going to show parentheses so we can show that we are substituting. So the opposite of our b value is 5, plus or minus the square root of, make a big, long radical sign. Under our radical sign, we have our discriminant, which is b squared. So we're going to put 5 in parentheses. We're going to square that. We're going to, it's minus 4ac. But what we're going to do is, just to help ourselves out, we're going to make it, add the opposite. So we're going to make that a plus a negative 4. We're going to substitute in our a value, which is negative 3. We're going to substitute in our c value, which is 2. So short of, I have that funny looking b squared right there. Okay, that's our numerator. All of that divided by 2 times our a value, which is negative 3. So now we're going to start just simplifying in pieces. We're not going to try and do too much at one time, okay? So we're going to take the opposite of the b value. Opposite of 5 is negative 5, plus or minus. Under this radical sign, we're going to do the squaring and the multiplying. So we have 5 that's getting squared, which is 25, plus we have negative 4 times negative 3, which is 12. 12 times 2, which is 24. So our numerator became a little bit shorter. And downstairs, 2 times negative 3, we have negative 6. We're only going to do one thing in this next step. X equals. We have our negative 5 plus or minus. We have the square root of, we're just going to simplify, what is 25 plus 24? That is 49. We still have that numerator divided by that negative 6. Okay, now we will take the square root of 49. So we have negative 5 plus or minus the square root of 49, which becomes 7, so our radical sign is eliminated. And we have our negative 6 downstairs. Now what we're going to do is we're going to break this into 2 problems because we have that plus or minus in there. So we're going to do x is equal to, we have a negative 5 to which we need to add 7. And then we have to divide by negative 6. And we have the negative 5, from which we should subtract 7, divide that by negative 6. So there are two solutions because there are two square roots of 49. So x equals, upstairs here we have negative 5 plus 7, that's 2 over negative 6. And we're going to finish that one up. We have 2 over negative 6, a positive divided by a negative is a negative. 2 6 can be simplified to 1/3. There's one of our solutions. We're going to come over to this one. Negative 5 take away 7. We have negative 12. Negative 12 divided by negative 6. A negative divided by a negative is a positive. 12 divided by 6 is 2. So we have our two solutions, x equals negative 1/3 and x equals 2. A parabola crossing the x-axis in two locations, 2 zeros. Okay, let's go on to our one on the back side of this. Let's see if we can rewrite the quadratic formula without peeking too much to the front. X equals, remember we have the opposite of b, plus or minus. We have that radical sign under which we have b squared. Remember we changed it to add the opposite, so plus a negative 4ac, and our denominator 2 times the a value. Well, we have a quadratic here that is not set equal to 0, so that's our first move. So how about we move this 9x plus 2 over. So we have to subtract 9x and we have to subtract 2 to get it off that side. So subtract 9x, subtract 2 on the other side also. We now have 5x squared minus 9x minus 2 and nothing left on the other side. We will make that side 0. Now we can say a equals, we have a 5, b equals, we have a negative 9, c equals, we have a negative 2. Now we will sub into our quadratic formula. X equals the opposite of, remember when we sub in, we're putting in parentheses. Our b value is negative 9. We have our plus or minus, radical sign, negative 9 in parentheses for b. That's going to get squared. Plus we have our negative 4. That's always there. Times our a value, which is 5. Times our c value, which is negative 2. All of that is the numerator, divided by our denominator, 2 times our a value, 2 times 5. Okay, now let's just start doing some simplifying here. The opposite of negative 9, 9. Negative 9 squared, 81. Plus, negative 4 times 5, negative 20. Negative 20 times negative 2, 40. And downstairs, 2 times 5, we have 10. Okay, x equals 9 plus or minus the square root of whatever 81 plus 40 is. That's 121, one of our perfect squares. So now we have x is equal to 9 plus or minus. The square root of 121 is 11, no radical sign anymore, over that 10. We have two solutions again because there are two square roots of 121. So we are going to add 11 to the 9 and we are going to subtract 11 from the 9. So we have, in our first one, we have x equals 9 plus 11, 20, divided by 10. That is 2. In our other one, we have 9 subtract 11, that's negative 2 over 10. A negative divided by a positive is a negative. And 2/10 we can simplify to 1/5. Or of course we could write it as the decimal 0.2, so it would be a negative 0.2. Okay, we again have two solutions, two locations where the parabola crosses the x-axis, two zeros, two x-intercepts, two roots, all those ways I said we could talk about zeros as solutions. Okay, let's go on to our next one, next page. When b squared minus 4ac are discriminant under the radical sign is not a perfect square, you will need to round the answer. You will need to approximate the answer, okay? Like we did yesterday in our square root method when we did not have a perfect square that we were finding the square root of. Okay, let's practice writing our quadratic formula. X equals the opposite of b plus or minus the square root of b squared plus a negative 4ac. That's our big long numerator over our denominator 2a. Okay, the first one we have here, we do have a quadratic already set equal to 0, so we can just go to identifying our a value, our b value, and our c value. So again, very critical that we first of all have it set equal to 0, and then that we identify those properly, so that when we substitute them in to our formula, we're going to be successful. X equals the opposite of, in parentheses, our b value negative 8 plus or minus the square root of our b value in parentheses squared plus a negative 4 times our a value in parentheses of 2 times our c value of 1. All of that divided by 2 times our a value in parentheses of 2. So notice all places where there's a variable except x in our quadratic formula, we are subbing in parentheses. X equals, the opposite of negative 8 is 8. Negative 8 squared is 64. Negative 4 times 2 is negative 8. Negative 8 times 1 is still negative 8. And our 2 times 2 downstairs becomes 4. X equals 8 plus or minus the square root of, we have our 64 plus a negative 8, 56. And that's all we're going to do in that step. Now in our next one, let's do some rounding here. Let's find the square root of 56 and round it to the nearest 100th like we did yesterday. So when you put the square root of 56 into your calculator, you end up with 7.48. So we have 7 and 4800ths with a 3 behind that 4800ths. So that 3 isn't big enough to change it to a 4900ths, so we will leave it 4800ths. And we also have to change one thing here. We have to, because we're rounding already in this step, we need to change our equal sign to approximately equal to show that we are rounding here. Okay, now we're going to do the same thing we did on the front, or the other sheet, I mean. 8 plus that 7 48/100 divided by 4, and x is approximately equal to 8. Subtract that 7 48/100 divided by 4. So we end up with x is approximately equal to, in this one it's 15 48/100 divided by 4. And that should come out to 15.48 divided by 4. That could 15.48 divided by 4. That should come out to 3 87/100. So we have a positive 3 87/100 as one of our solutions. And we'll come over to the other one. We're going to be subtracting 7 48/100 from 8, so we get a 0 52/100. That's going to be divided by 4. And when we divide 0 52/100 by 4, we should get 0 13/100. So there's our other solution. So again, we have two solutions, 2 zeros, 2 locations where this parabola crosses the x-axis. So we have to do some rounding. And of course, if they asked you to give the exact, we would have to simplify our radical and work from there. But we're not going to work with exact in this one this year. Okay, let's go to our very last problem. Okay, this one we have our 3x squared minus 15 equals 0. Something should be staring you in the face right now saying, you know what? I said you can use the quadratic formula for any quadratic function, but maybe we could use another method also. It's already said equal to 0, so let's just look. We have a equals 3, we have b equals 0, we have c equals negative 15. Oh, this looks like one of those, you remember just what we just did yesterday. We could add 15 to both sides and we could have our ax squared set equal to our constant, our c term. We could divide both sides by 3 to get our x squared. And now we're going to have x squared equals the square root of 5. Take the square root of x squared. Take the square root of 5. We're going to have to round, so we're going to use our approximately equal to. We know there's going to be a positive and a negative square root. And when we take the square root of 5 to approximate it, we get 2 23/100 on our calculator. But that 23/100 is followed by a 6, big enough to round it to a 24/100. So we will make this x is approximately equal to the two solutions. We have a positive 2 24/100. We have a negative 2 24/100. Now, had we used the quadratic formula, we would have gotten the same solutions, just would have had to work harder. So the quadratic formula will solve any of them, but then when you recognize that there's another method to use, be smart and use it. Okay, let's get to work on our homework.